the data, the data that we started using. I hope you remember the one we used to do the classwork. In fact, between the day we met and I think today, I also uploaded a certain data. That data is a past question. Mhm. And so I wanted you to try your hands on that one as well. I want to believe you did just that. I want to believe. Okay. The data on a site proposed for the development of a tourism complex at UCC was surveyed with a compass and the following were recorded. Line AB, 233 degrees, length in meters, 728. Line BC, 108 degrees, length in meters, 519. Line CD, 163 degrees, length in meters, 365. Line DE, 80 degrees, length in meters, 930. And then EA, we have 305 degrees, length in meters, 1100. Using a suitable scale, plot the above traverse for the tourism complex at UCC and adjust the error of closure if any. That is what we are coming to do. Adjustment of the error of closure. Now, this data given you should tell you that it is a closed traverse. This is a closed traverse. And so, after plotting, you should end exactly at where you started the plotting from. If you do not get there, it might not be your mistake because probably you followed all the principles, only that you couldn't get there. Now, when that happens, you attribute it to error, okay? And so you create a gap, error gap, or error of closure. And as a surveyor, you are not supposed to leave people in limbo because what you have plotted, which has given you that error, is supposed to be given to somebody. For example, it is somebody's piece of land. So you have plotted my land. My land doesn't have any break, but what you have plotted, there's a break, there's a gap. So a good surveyor may want to adjust it, all right, may want to correct it. The correction is what you refer to as adjustment, adjusting the traverse, all right. Uh, if you go onto the slides, we are still on unit 3. If you go onto the slides, you'll find that the adjustment procedure was added. I added the adjustment procedure, which I believe some of you have seen. Hmm? Yes. So that is what we are going to go through this evening, trying to adjust error. But before then, or before that, we will try and plot this one, the one I gave you. As for the one on the slide, we have done it, and I told you also to go and practice more and more with it. We are coming to do the one I posted on your platform this evening. After that, we will look at whether what you did was the right one, for which reason you can pat yourself at the back, mhm, or you went wayward. You want to have a look at it. You want to look at that. After that, we will try and adjust the traverse because obviously, once the question itself is demanding adjustment, it means the traverse will not close, even though it's supposed to be a closed traverse. So that is what we are coming to do, plotting first, and then adjustment second. Adjustment takes a lot of time. Adjustment of the traverse takes a lot of time. And so if you manage to do it once, I take my time to do that. But I expect everybody to grab it and I expect everybody to come online so that we all will have a look at it. At the moment, you are how many? How many? Less than. Okay, let's mention the names. Abdurrahman, as usual, he's always here. Azimarik, Alex, Abba, Apia Kubi, Elijah, Dominic, Barnes, Emmanuel Chumasi, Margaret Shre, Noah.
Please, who is the slide? This evening slide. Please send it on the page, okay? The one having it.
I do not have it. So if anyone want, it's like the page the last sent us to join. I wanted to join, but the administrator did not approve my permission for me to join. So some of us are not in that platform. So there's another platform that some of us are in. So if you can kindly send it to us, it will be very helpful to us.
Sorry for the interruption. Sorry for the interruption. Yeah, a call came through and I had to attend to the person. I hope that will be the last call. Okay, so as I said, we are going to use this data. But you see, the the error is quite a lengthy process. It is not difficult, but because we have to take our time and monitor the steps closely, it will it may take the whole of the time. It is not difficult at all if you know how to do it. All right. Therefore, we will do two things today. And
Doc,
as I told you the other day,
hello, Doc.
after hello.
Yeah, sorry to interrupt. Please, some of us we don't have the question that you sent. So if those who are on the in the class, if they can kindly send it to us so that we can all be on the same page, and then we can be.
No, does it mean you are not on the WhatsApp platform?
The platforms are two. So the one that we had, the slide was not sent there. So the other one
Oh no.
we are not privy to that one.
Uh,
Yes,
hey, then so how did you get the previous
it
slide?
was one of the guys who sent it to me.
No, then it is not good enough. After the course, you can decide to collapse, it, but for now, we are using it for the course. So find a way of getting onto the platform.
Yes, I like
Vanessa, I don't know whether
the link, but it's like the administrator has to approve my joining, and the administrator did not approve. So that's why I'm not able to join that platform. So if they can send the
uh,
link so that we can join, it will be good for us.
so now where do they place it? Where is it? Where should it be placed?
Uh,
Okay, so let me dictate so that you can also
I think
put it
somebody
down. In order that you will not
paste
waste
it on
time.
our plus, so I've gotten it. So
Uh,
we can,
okay, so those who have it, please post it now for him
yeah,
to have a copy. On the other hand, I wanted also to dictate so that you put it down quickly and then you move
yeah,
on.
I've gotten it, so we can proceed.
Okay, is that good? Thank God. So we're going to look at how the plotting will go. Now, as I said, in examination, having been given such a table, um, the bearings are usually not adjusted. We leave the bearings as they are. But where we do adjustment or scaling is the distance, the length in meters. So to solve this question, it's a past question. That was a 2023. All right, this is a 2023 past question for which students, which I will forward the whole question onto your platform. I have promised giving you a number of these questions. Okay, so um, it's a past question. So when they give it to you like this, you have to copy and complete the table. How do you copy and complete? The question under it says that you should use a suitable scale. Now, what is a suitable scale? That is the completion I'm talking about. Choosing a suitable scale, to bring the lengths to plottable units. Because 725 meters, 1,100 meters is way too long. 1,000 meters is even more than 1 kilometer. Okay, so how do you plot this? Therefore, you choose a suitable scale. And the scale that you choose must be guided by two things. You must be guided by the, the longest length and the shortest length so that you will not have the shortest length getting swallowed or the longest length getting too long, say that your paper cannot accommodate it. All right. So over here, our shortest length is 365 and the longest is 1,100. So you choose a scale that can give you, something manageable, something manageable. And the scale should come in the form of using the imperial system. I hope when they were taking you through map reading and map interpretation, they mentioned imperial and metric. Using the metric, not imperial, I mean. So there are two units of measurement. We have the metric and the imperial. Okay, so the imperial given to us by imperial masters, the British style, where we have inches, feet, yards, miles. If you hear any such thing, belongs to the imperial system. And then if you hear all the ta, then we are talking about the metric system. The word metric comes from meter. Meter. So all the units of measurement that end with that end with ta, they belong to the metric system. The centimeter, the kilometer, millimeter, which one again? The meter itself, kilometer. So here you choose your scale in the metric system. So it will be 1 cm to something. So let us all suggest. What do you suggest should be the scale? 1 cm to what?
Please, 200 meters.
1 cm to 100
Meters.
meters. Okay. So if you pick it like this, you have to do simulation. You have to simulate. In other words, you have to try and see how your lines will stand in terms of their lengths. So 725 will give you 7.25, which is manageable. 519 will give you 5.19, still manageable. 365 will give you 3.65. And so the last one will be the 1001. That will give you 11. Will it not be too long? 11 centimeters. Will there be a paper like that? And so, as I said, after you have gotten the table, you create another column. You say scaled distance, all right, or scaled length in meters, depending on the heading that will be given. Sometimes you use distance, sometimes you use length in meters. So you create another column, and then you use your scale to scale it down. So that column will have 7.25, all right, centimeters. Please add the unit of measurement, because if you leave it big, nobody will know what unit you are using, and so on. So now we know what to do for a start. Having gotten this, you have to also do the rough sketch to give you a rough idea as to how your diagram will look like, as to how it will look like. Okay, in exam room, this will not take any lengthy time. Just a few minutes, you'll be fine. Okay, so you do your start. That is the cardinal setup. Okay, you do that one, and then proceed from there. You do that one and proceed from there. So let's have it done. Let's have it done. Start with the cardinal setup that we did the other day. Okay. Now, when you do that, you start with 233 degrees. And you know 233 degrees will be in the third quadrant. All right. So you use your mind's eye between 180 and 270, rough sketch. This one, we are not using the protractor at all. We are only using rough sketch to see how the diagram itself will look when indeed you start the plotting. Okay, so how will it go? How will it go? I hope you are doing the sketch. Okay. So you realize that your sketch is giving you a figure. The first one is 7.25. Then when you're at 7.25, the next one is 108. You know, 108 will be in the second quadrant. So that one too will give you 5.19. So you do it. Then at 5.19, the next one will give you 163. 163 will still be in the second quadrant. So 163, that will also have 3.65. So you do it at 3.65. The next one is 80 degrees. It will be in the first quadrant. And the 80 degrees is mounting on to 9.3 centimeters. So that one too, you cut 9.3 is quite long, you know. Okay, so at 9.3, you are now going to construct 305. All right, so after 270, 305, and that is 11 centimeters. So it will take you all the way up there. Okay, so now you have gotten the shape and how it looks like. This one, no protractor, freehand. Freehand, that is what you use. So what you have to note here is that you have to start from somewhere close to the top right corner of the sheet you are using. Top right corner. Close to, not too close to the top, not too close to the corner. Okay, so that your diagram will fit onto the paper. That is one essence of the sketch. It gives you an idea as to how the diagram will look like so that you can position it properly. I've seen people who have started plotting and eventually they have to rub it because it got to a point their diagram was going out of the paper. All right, it was going outside the paper. I don't want that to happen to you. That's why I said you can start from top right. If you're using the vertical type, if you're using the horizontal, that one you can start maybe anywhere from any point. Okay, so now let's bring our protractor out. Protractor out. Bring out your ruler. Bring out your pencil. Bring out your eraser. Right? So these are the instruments that will be needed. Okay. So with your, we are starting the plotting. With your ruler, you make your cardinal setup. You start with that one. And make sure that one is, the lines are straight. Your perpendicular line, I mean the north-south line, should stand according to the margins of the book. It should stand straight. Then the one you're going to cross, that is the east-west line, should also stand straight. All right, which I believe with the margins of the paper, you can easily do. And your lines shouldn't be anything longer than 2 centimeters. Even 1 centimeter across is okay. But just so you see it clearly. So always try and see whether you can get 2 centimeters. It doesn't also mean you should always pick the ruler and measure 2 centimeters. At least use your mind's eye to measure 2 centimeters. You'll be fine. So now we have done our first the distance, the cross, if you like, the cardinal setup. Having done that one, which I believe all of you have done, any problem anywhere, simple. Let's move on. Having done that one, the first bearing you're going to plot is 233. 233. So how do you get 233? 233 is more than 180 but less than 270. So it means it is inside the third quadrant. That means that you have already cut out 180. 180 is gone already. Okay. So what you do is that you subtract 180 from 233 and the difference you plot. So 233 minus 180, what is the answer?
That'll be 53.
It will be 53, right?
Yes, please.
Okay, so that is what you are going to plot. Now, how do you get the 53? You are going to use the north-south line as your base. So the baseline of your protractor must lie on the north-south line. Then the perpendicular line, that is the 90-degree line on your protractor, must lie on the east. No, the west. Must lie on the west. So the curved part of your protractor will be on your left. What I call stomach. The stomach of your protractor will be on your left. Okay, at this setting, at this position, you are good to look for your 5-3. So you start reading from the outer scale. You have 0, 10, 20, 30, 40, 50, 60. And here we're talking about 6-3. So you find it somewhere there, you place a dot. Okay. Having placed the dot, what next you are going to do is to take away the protractor and connect the dot and the center of your cardinal setup. You connect the dot to the center of your cardinal setup. Now, as you are connecting, you are not just connecting. You are connecting according to the distance that you have on the table. So you put your ruler to the center. Let the beginning of the ruler be at the center of your cardinal setup, and let the other side pass through the dot that you placed. On that ruler, you are looking for 7.5 centimeters. On that ruler, you are looking for 7.5 centimeters. So when you get the 7.5 centimeters, you place another dot and discard the first dot. You will discard the first dot. Okay. Then from the second dot, you rule the line straight. Go and join the center of the cardinal setup. Okay, so now you have that one done. That is 7.25 centimeter line. Okay. Now at this point, you make another cardinal setup. Your lines should be straight, as I said, passing through the dot where you constructed the line. When you do that, you find that the 7.25 and the 233 line will be at the top there. That one is okay. We understand that way. Okay, so where you have done the second cardinal setup, that is your B. I forgot to let you write A at the starting point. So write A at the starting point. And then the second cardinal setup over the right B. So you have constructed line AB. That's what you have done. Okay, so now we're going to construct line BC, which has a bearing of 108. Anybody lost? Are you all home? Are you all home with what you have done so far? Okay, I take it that you are all okay. Now let's move on. Let's move on. So at B, we're going to construct BC, and the bearing is 108. 108. 108. 108 is less than 180, but it is in the second quadrant. So this one, you have just a little to worry about. I mean, how do you position your protractor? So simple. The north-south line will be your base. So let the base line of your protractor fall on the north-south line. And then the perpendicular line will fall on the east line, the line to the east. So it means that the curved part of your protractor will face the right, or the stomach will look to the right. Now from here, you can get your 108, okay, using the outer scale. So you start from 0 all the way to 100, and then we have 110. Between 110 and 100, 108 will be there. Okay, so you look at it. Oh, it's what? 108. Yeah, 108. Between 100 and 110, you have 108. So you look at it and place a dot where the 108 is. Okay. Now the protractor has finished its work. You put it somewhere, and then you look for your ruler. Now, put the ruler, the starting point of the ruler, the 0, at the center of your cardinal setup at B. And let the other side of the ruler pass through the dot you just placed. Okay. That done, you are going to construct 5.19, or look for 5.19 on your ruler, centimeters. Sometimes the decimals will, but just after 5, you get it somewhere there. Between 5 and 5.2, you get 5.19 over there. So you place it there, and then you discard the first dot. You discard it. Sometimes the line will not get anywhere close to the first dot. Don't worry about it. What is important is that your line is connecting with the first dot, which is the degree you constructed, the angle you constructed. So here we're constructing 5.19 centimeters. Now, with that second dot, you connect the center of your cardinal setup with the second dot. I hope you have done it. Okay, so that will be 5.19. As soon as you hit that dot, the second one you placed, you are done. So you do another cardinal setup over there. Your perpendicular line first, and then your north-south line will come second. That one too, you have to be careful. All right? You have to be careful. Sometimes your horizontal line, that is the east-west line, will come down the dot so that the line will be up there. In this specific case, that's what it is. After you have done that, you write C. So you have succeeded in constructing line BC. You write C. Moving on. You're going to construct CD. You're going to construct CD. CD has a bearing of 163 degrees. 163 degrees. And as soon as you hear the bearing, you should be able to determine which quadrant it lies in. This is in the second quadrant. It is less than 180. So you will not struggle at all. The same procedure you use to construct the 108, the same procedure. So the base of your compass will be on the north-south line. And then the perpendicular line of your protractor will be on the east line. At this position, you can have your 168. Is it 163? Yeah, 163. So from 130 outer scale, 130, 140, 150, 160. So between 160 and 165, you find 163 somewhere there. You place a dot over there and put away the protractor. Put away the protractor. Now pick your ruler, as you have been doing. Put the center, the starting point of your ruler at the center of your cardinal setup at C. And let the other side of your ruler pass through the dot you placed. Okay. Now, at this position, you are measuring 3.65 centimeters. 3.65 centimeters. So you look on your ruler, wherever you get the 3.65, you put a dot there. So at this juncture, you have 2 dots. 2 dots. You discard the first one because that is only a guide. You discard the first one. Okay. So with the same ruler, you can connect the dots to the center of your cardinal setup at C. Done? Okay. Now, having done it this way, you now start your cardinal setup again. This time, starting with the horizontal line because of the nature of the line. You cut your horizontal line, and then through the dot you place, you construct your vertical line. Okay, so that has been done. As soon as you finish with that thing, you write D. So we have succeeded in constructing line CD. I hope everybody is following. Nobody has fallen out.
Hello, sir.
Yeah, I'm here.
Sorry for the disturbance. There's a heavy rain at my place here, and then my line keep on going off, and so I have to switch device. Please, the scale that you are using, I've chosen my scale, but I just want to be in line with you. So the scale, I just need the scale that you are using.
Oh, somebody suggested 1 centimeter to 100 meters.
1 centimeter
to 100 meters. You just don't choose the scale. You consider the largest figure and the smallest figure.
Yes.
So if you choose this, you see that all the other figures will be, apart from the last length, which is 1,001, which will give you 11 centimeters. The rest are quite manageable. Because if you choose anything less or more than this, the other figures may disappear. For example, the 365. If you choose any scale that is bigger than the 1 centimeter to 100, 365 will dwindle, and the line will be that short. Okay.
Yeah.
So I think the 100 centimeter, 1 centimeter to 100 meters is quite manageable. And so that is what we are using.
Yeah, exactly. That's what I choose, but I just want to be in line with you guys.
Okay. So it means that you couldn't follow the plotting from where we have got into.
Yes, so but I will do it.
Oh, you do it. All right. That's fine.
Yeah. The rain is so severe here.
Yeah, it rained here where I am in the afternoon, but it didn't rain for long. So now we have plotted CD. We have plotted CD. We are now moving on to DE. DE. Okay. So at D, we're going to plot DE. DE has a bearing of 80 degrees. 80 degrees. It is less than even 90. So the same procedure. Use the north-south line as your base. Let the baseline of your protractor fall on the north-south line. And let the perpendicular line on your protractor be on the east line. At this position, you can have your 80. If you remember, you started using the protractor constructing 80 degrees. You can have your 80, and you are using the outer scale. So you see your 80 somewhere there. You put a dot over there. Okay. Now, that done, switch device. Put your ruler there as you have been doing. The center of your, the starting point of your ruler should be at the center of your cardinal setup at D. And then the other side of your ruler must touch or pass through the dot you just placed. Okay. At this position, you are good to construct your line. You are looking for 9.3 centimeters on the ruler. I believe this one will go beyond the dot you placed, but if it doesn't go beyond it, all the better. So 9.3. Just after 9 centimeters, you see some 3 there, and then you get it. Okay. So I assume you have gotten your second dot, which means the first dot is useless now. With the same ruler, join the second dot to the center of your cardinal setup. Okay. I hope you have done it. Anybody lost? Good. All of you are home. All right. Now we are on the last leg. We are going to plot EA. EA. As soon as you see A on the last line, it should tell you that that is a closed traverse, even before you start plotting in exam room, because you started with AB. So if you are ending with A started it and A is ending it straight away, that is a closed traverse. So we're constructing EA. Let's not forget, at this point, you have to do your cardinals now. So do it. Okay. Now, how you do the cardinals also determines your accuracy. Always look at where the thing is coming from. Some of them will be at the top, others will be at the bottom. All right. This one, for example, the line D, is supposed to be at the bottom of the cardinal setup you just did. Okay, it should be at the bottom there. Okay, so we are good to go now. Let's construct angle 305 degrees. 305 degrees. Okay, so how do you proceed? 305 is in the fourth quadrant. It's in the fourth quadrant because the fourth quadrant is between 270 and 360 degrees. And so it means that you have already cleared 270. You have cleared 270. Therefore, you subtract 270, all right, from the 305. So it will be 305 minus 270. What will be left for you to plot? What will be the answer?
35.
35.
Yes, sir.
Okay, so you are going to plot 35 degrees. How to orientate the protractor is the biggest issue now. Okay, so this is how you're going to do it. The horizontal line, the east-west line will now be your baseline because you have cleared the 270. So now you are going to start from 270 up or 271 upwards. So the east-west line will be your baseline. Therefore, let your protractor lie on the east-west line. I mean the horizontal line of your cardinal setup. Okay. And let your perpendicular line lie on the north-south line. That is the vertical line. Okay. At this position, you are well set up. And so you can find or look for your 35 degrees. This one is not difficult to find at all. It is not difficult to find at all. So you see 35 somewhere there. You put a dot there. Okay. Finished? Now pick your ruler. As usual, let the starting point of the ruler fall at the center. Oh, I forgot. This point is E, so write E. Fall at the center of your cardinal setup at E. It will be over there. And let the other side of the ruler pass through the dot you placed. Having done that, you are now going to look for 11 centimeters. 11 centimeters on the ruler. Okay. So if it passed through the original dot, now you have another dot. You have another dot, 11 centimeters. So discard the first one. And now connect the second dot to the center of your cardinal setup at E, as you have been doing. Connect. Okay, I believe you have done that. Now, what type of shape have you drawn? So you realize that even with the 11 centimeters, it will still not take you to the starting point. It will not. It will not take you there. So at the end of the 11 centimeters, you can do another cardinals over there. All right. and that should have ended at A. The 11.11 centimeters should have taken you to A straight, but I didn't. And so where it ended means that there's another A because your traverse is supposed to end at A. It didn't end at A. It has ended at another point. So that place will be another A. This time, A prime. A prime. I hope you know how to write the A prime. So we are done with the plotting of the traverse. So between A, the original A, and A prime, there is some space. That space is known as error gap or error of closure. Error gap or error of closure. Blame yourself not, because the error of closure is most times not your making. All right. It could be as a result of something called local attraction. It is part of the chapter 3 that I gave you, local attraction. Okay. That gave you wrong readings. I've told you that prismatic compass is highly magnetic. And so if you are operating with it at a place where there are magnetic materials, objects, it is not good. In fact, one thing is, or the precaution is that when you are going to use the prismatic compass, you don't have to wear ring, no chain. The woman, no earring. There shouldn't be even coin in your pocket. Don't wear an attire with press button. Nothing metallic should be around you. Ideally, your belt hook should be put somewhere. Ideally, because it is metallic and the prismatic compass is magnetic. And you know how metal and magnets behave. One is going to attract the other. It is this that we refer to as local attraction. So if there is error of closure, apart from it sometimes being the mistake on your part in terms of the plotting, to a large extent, it is coming from local attraction. And as I said, local attraction as a subheading is part of the chapter 3 that I gave you. So you look at it and read. But except is what I've given you. Okay. Except is what I've given you. Look, I think it is slide 56 on the chapter 2 and 3 that I gave you. Local attraction. So you find it there. Now we now have our gap. How do we adjust it? How do we correct it? That is the adjustment. Okay, so if you go to slide, the slide that talks about adjustment. If you go to slide, I think slide 48, slide 47. Yeah, it starts from slide 47. In fact, it is even at slide 46. 46, it starts from that point, adjusting compass traverses. All right, then it takes you to 47. It takes you to 48. It is at 48 that the instruction how to go about the adjustment can be found. And we call it the Babbage rule or the graphical method. And what does this one do? It seeks to distribute the error over the points you have plotted. It distributes the error over the points you have what? Plotted. The traverse legs, that is from B, C, D up to E. A will not take any of the distribution because that is the starting point. You cannot be wrong at the point where you started. The error will start coming from the second point, that is the second stage in B, C, and so on. And so you distribute this error. At the end of the day, you get a solid diagram. That is what we are going to do. I'll not take you through what is on slide 48. You do the practical so that when you read what is on slide 48, and let me place on record that slide 48 is not part of the course book. I provided it as part of the slides. Okay, even though there are excerpts of it in the book, the detail as I put here is not. The book captures it all right, but it doesn't even make mention of the bondage. All right, so I decided to expand it and make it as I have done. Therefore, we are done with the first phase of our meeting this evening. We're going to the second phase, which is adjustment of traverse. As for the plotting, we did it the other day, so at least you have some rough idea. Maybe you couldn't practice and so, but still you have some rough idea as to how the plotting goes. So, but what we are going to do next, you haven't done it before. And so let's start. The first step is to identify the error as it is over there. The second step is to provide dotted lines to connect the A and A prime with your ruler. Okay, do a dotted or dotted lines to connect the 2 points A and A prime. I hope you have done that. Okay. So not a solid line, broken or dotted lines, whichever way you call it, or whichever name you give to it. Okay, now they are connected. All right.
Hello, sir.
What? Yeah.
Please, can you take that place again?
Oh, I just said connect A and A prime with dotted lines or broken lines.
Okay.
Using your ruler. Are you done?
Yes, sir.
Okay. Now let's move to the next step in adjusting the traverse or adopting the Bowditch rule. With your ruler, we are going to measure all the lines we have constructed again. We are going to measure all the lines we have constructed. So you do another table or something like a table. So you write line AB. AB. You can simply write AB. Okay. If you write AB, you put equal sign there. You pick your ruler and measure what you have plotted indeed. Because some of the trouble could come from the plotting. So measure what you have plotted. And that is to come from the center of your cardinal at A, cardinal setup at A, and your cardinal setup at B. That line that joins the two. That's what you are measuring. Sometimes you find that your line will be slightly different from the actual distance you should have, plotted. Sometimes. Don't worry, it is part of the adjustment. So, for example, this one, you should have plotted or constructed 7.25 line. You measure and maybe you get less or more, just a little. Don't worry, just write what you have measured. So instead of 7.25, maybe you get 7.3, 7.2, all right, and so on. That's fine. So AB is equal to what you have measured now. I hope you have written it. Okay. Now do same for BC. 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 Okay. So you measured BC. What did you get? Okay. So whatever you got, you write it against BC. As I said, it could be less, it could be more than what actually you should have constructed. Good. Now let's go to CD. Line CD. Finished? CD, what did you get? What you got, it should be something in the region of 3.65. You can get 3.7, 3.6, like that. Just put it down. So you record that one too. Then you go to DE. You go to DE. You measure that one as well. What did you get? You write it against DE. Okay. Then the last one is E against A prime. That is EA. EA. Whatever you got or you get, you write it against that one. Okay. So now we have measured all the lines you have constructed. We have measured all the lines you have constructed. What are you going to do with them? We are going to sum these figures up. Put the figures together. Put the figures together. What did you get? Okay. What did you get?
Oh. 36.45.
What?
36.45.
36.45 or
45.
Your line is disturbing, Ajima. Anybody with a better line? Let's hear you. I didn't do the calculation actually. What figure did you get?
37.
No, don't round it up for 37 or 36.
Okay, 36.67.
Yes, leave it as it is.
Okay.
36.67 centimeters. Okay. Okay. Now, that is a part of what we are supposed to do. This 36.67 is supposed to be a horizontal line. In other words, you are going to draw a horizontal line standing at 36.67. How long is the ruler in your mathematical set? How long is it in terms of centimeters? Ruler no crowd.
15.
So from the mathematical set, the ruler inside is 15 centimeters.
It's 15 centimeters.
Yes, 1.5 centimeters.
Okay, 1.5 centimeters. All right. Now, if you have to construct a line standing at 36.67, will there be enough space for you to construct that line?
No, sir.
There wouldn't be enough space, correct?
Yes.
All right. So what do you do then? Anybody? If you go on to slide 48, that solution has been provided. That is under the second bullet. If the line is longer than an ordinary paper can contain, choose an appropriate scale with which the distances can be reduced. You get a point? That is the solution. So if what we have done is too long for a paper, because we're going to construct this line, if it is too long for a paper, what we have to do is to choose a scale. All right. And that scale you will choose will affect any subsequent measurements that we will do. Any subsequent measurement. So for a start, let's choose half, a scale factor of half, meaning we are going to divide each of the distances measured into two. And that is also to say that the 36.67 is also going to be divided into two. In fact, there are other ones, other plottings that will give you just a small line. So you wouldn't go through this. But it is good you are starting from here so that you will know what to do if in case you get there. So simply, our mathematics will be 36.67 multiplied by 1 over 2. Are you following the mathematics?
Please, come again.
I said we are choosing a scale factor of half. In map reading, map reduction, we have scale factors. Scale factors are always in fractions. So this fraction half means that all the distances there are going to be halved. So you can start with the total we have done. And this I'm saying that our mathematics, because we want to reduce the 36.67 down, we want to bring it down. And the solution is that we have to choose a suitable scale factor or a suitable scale. Okay, so our scale is half, or our scale factor is what? Half. And so the mathematics will be 36.67, which I know you know how come we have 36.67 multiplied by 1 over 2. You see that every whole number is over 1. So you get 36.67 over 1 multiplied by 1 over 2. So you can cancel, you can cross out. So invariably, you will come to 36.67 divided by 2. Are you all home? Is everybody home? Is everybody home? Nobody is lost.
Yes, sir.
All right, good. So what is the answer? 36.67 divided by 2. What is the answer?
Please, 18.335.
18 point
18.335.
18.335. Somebody's hand is up, Ima.
Hello, sir. Sir, please, it's raining here, so my line got off before I came back. About measuring the distances, is A to A prime part before getting the 36.67.
About mentioning what did you say?
The distance from A to A prime, since is it also part of it?
Yeah, everything you have constructed is part.
Okay.
So when you put all the figures together, you get 36.67.
Okay, sir. Okay. I thought
But
the
I hope you know. Did you hear what we did? In other words, what followed after the summation?
yes.
Okay, good. So we are at a point where we are scaling the distance down. So we
Yes.
have 36.67 multiplied by 1 over 2. And as I said, every whole number is over 1. So 36.67 divided by 1 multiplied by 1 over 2. You come to 36.67 divided by 2. When you punch your calculator, your final answer will be 18.35, which I believe is a manageable figure with which we can construct a horizontal line. Correct? Akuye? Okay. Now, you knew where they are adjustment. You haven't gotten anywhere. And let's go to the next stage. The next stage is construction. Look for an empty space, some space, and construct a horizontal line measuring 18.35 centimeters. That has been done, I believe. I believe that has been done.
Doc, an empty space where we have not drew anything.
Yeah, where we haven't drawn anything, yes. I don't want what you are going to do to conflict with the plotting. So it shouldn't be that big, something small about, if you get about maximum 6 lines, you can do this work.
Okay.
Hello, sir.
Yeah.
Please. What happened to the way the network is? I didn't get it from where you say we should submit.
Hey, don't worry.
Wow, the network may have me panic.
Hey,
I have to go up and come back.
Serious. Okay, I think your yes. Can somebody provide a summary of what we have done from the summation all the way up to this point? Okay, so after the summation, all the measurements we did, we summed them up, and we got 36.67. Okay, now with this figure is supposed to be used in constructing a straight line, a horizontal line. But you find that 36.67 is too wide, too big. There wouldn't be any paper. There wouldn't be any paper on this planet to help you do that. So what do? As I said, the solution is on the slide. Slide 48. If you go to slide 48, the second bullet, under the second bullet, the solution is there, which says that if the line, I mean the 36.67, if the line is too long, all right, it's longer than any ordinary paper can contain, choose an appropriate scale with which the length, the distances can be what? Reduced. I hope that is clear. So that is
Yes,
what that is what we are going to do. And so the scale here is supposed to be in fraction or in decimal, but over here you prefer the fraction. and we chose a scale of half or 0.5. Okay, that's our scale factor. In dealing with scales and so on, we talk about scale factor. I hope you have heard of scale factor before.
Yes, sir.
Scale factor of half. So what do we do with the scale factor? We use the scale factor to reduce the length, that is the 36.67. So the mathematics will be 36.67 multiplied by 1/2. You will find that you can also write a 36.67 over 1 multiplied by 1/2. Every whole number is over 1. Now, at this point, you can simplify it by writing 36.67 divided by 2, or 36.67 over 2. Okay, without doing calculations here and there. Now, calculators are available. So 36.67 divided by 2 will give you 18.35 centimeters, which is a manageable figure for any horizontal line. So that is where we have reached.
Thank you.
Yeah, I hope you are home now with us.
Yeah, very well at home.
Good. So now with the 18.35, we are going to construct a horizontal line. So I told them to look for some empty space, a space where nothing has been written. If it's an exercise book, you leave about 6 lines in that exercise book and you'll be fine. About 6 lines, so that it doesn't conflict with the plotting you have done. Because we are not done, we will go back to the plotting you have done. So construct a horizontal line standing at 18.35. Okay. I hope you are there now. Correct. Now, you can, so at the edges, mark the end of 18.35 line. Mark it, so that you know this is the line. It will stand out clear. Okay, having marked it, you are going to write the alphabet A. The alphabet A at any of the ends. I prefer having it. Maybe let me follow what the book has done. I prefer having it on the right hand side. On the right hand side, yes. On the right hand side. Okay. Now having written the A, what next are you supposed to do? We are going back to the plotting we did. So some measurement is going to be done again. And what type of measurement is that? You see, we provided some dotted lines to connect A and A prime, if you remember. So you are going to measure the space between A and A prime. Pay attention, because it takes time. Therefore, I may not get time to come back to it again. After today, the next time we are meeting will be the last meeting. I hope I'm right. Unless we plan for another extra meeting. So you pay attention and follow the steps. At least maybe you will have time to do only one adjustment as you are doing. So measure that space, the dotted line, from the center of the cardinal setup at A and the cardinal setup at A prime. Measure. Here, to be accurate, you use the divider to be accurate. You use the divider. So the divider can get you the exact center of the two places. When you finish, you transfer the divider onto your ruler and measure. All right. I hope you got some figure. So everybody will give me his figure. And let's see where the figure will fall. Who will come close? I didn't do the measurement, so I'm relying on what you did. Okay, so who is ready with his figure? You had
Please,
3.1.
please, the A and the A prime. After drawing the cardinal, what should we do again?
What cardinal?
Where we have to. You said we should go back to the figure we drew. And that is why I couldn't get it well.
You see, there are a lot of things to do, so you have to follow religion, especially if you can hear me well. Going back and forth with the layers. I said the gap, the space there should be measured. If you take your mind off 1 second, Krana, you miss something. The space there should be what? Measured. I hope you have done it.
At 3.1.
You have 3.1.
Yes.
Okay. Who else? Who else? Oh.
Sir, please, 2.4.
2.4. Hey, wow. Who else? Don't worry, you are not wrong. That is what you have plotted. So you use your figure, but I just want to,
Hello, sir.
Who else? Yeah.
2.2.
2.2. Who else? It means that the one who has 3.1 should go back and measure again. Because 2 of those who have done it are giving us figures that are closer to one another. Hey, you are many.
Sir,
I want to hear all
I
of
got
you.
3.
You got 3.
Yeah.
Wow. Okay, 3.0. All right, who else? Hey, if I don't know, only 4 people have done it. You see, some people come, but they are not participating in what we are doing. It was a mamini. Yeah. Because how many are you?
Is it the distance from A prime to A or?
Abba. Somebody answer him.
No, my network was like the network was disturbing me, so I didn't get it. I only had A to A prime, so and then the network went off. That's what I'm asking.
Okay. Yeah, so the gap between A and A prime is what you are measuring.
That one I had 4.
Hey, you had 4.
I had exactly 4 centimeters.
That gap.
Yes, sir. Yes,
Okay.
sir.
Who else?
The distance between A prime and A, I had 4.
The gap, not the distance. The gap.
The gap. But the gap from A prime to A. I had 4.
All right. Who else?
4 centimeters.
Okay. Who else? Margaret, did you do it or you didn't do it?
Sir, please, I did it.
What did you get?
That means I have 2.9.
2.9. So why are you quiet? I want everybody, at least as many of you as possible, to give me what you had so that you can get a fair idea as to what the gap should be.
Sir, please, I got 3.1.
You got 3.1.
Yes, sir.
Okay. So you are with the first contributor. He also got 3.1. Somebody got 4. So the 4 will be an outlier. And those who got 2.2, you're also becoming an outlier because you find that we have 2.9 here, 3.1, which are closer. And then we have 3.0 within that range. And then somebody is coming with 2.4. So it is making the 2.4 an outlier. That is to say, figures that are not looking correct. Maybe how you plotted it and so on. Yes, who else? An answer? Okay, let's work with what we have. Now, it doesn't mean pick somebody's figure. Whatever you got, maintain it. That is according to your plotting, so maintain it. Now, what are you going to do with each of the figures you got? Whatever figure you got, remember what you did with the summation. We scaled it down. So if you got 3.1, it is going to be 3.1 multiplied by 1 over 2, which will be 3.1 divided by 2. How we have gotten that one too? So do that. Whatever figure you got, the one who has 2.4, 2.4 divided by 2, 2.2, you do 2.2 divided by 2 in that order. That is according to your. I am not done with you. So do it, and you have another figure. You have another figure. Okay.
1.55.
I hope everybody has done it. Okay, let's move on to the next stage. With the current figure that you have after the division, you are going to construct a perpendicular line. Listen to the word. A perpendicular line at the place where you wrote A. That is on the horizontal line you drew, the 18.35 line. You are constructing a perpendicular line standing according to your calculation. Okay, the one who had 2.2, you have 1.1. The one who had 2.4, you have 1.2. The one who had 3 will have 1.5. The one who had 4 will construct a line standing at a perpendicular line standing at 2 centimeters. If you had 2.9, you are going to construct a perpendicular line standing at 2.45 or so, like that. That's what I mean. I hope you know perpendicular line, vertical line. At the point where you wrote A, is everybody home? Teaching surveying, plotting online is not easy. It is not easy at all, I tell you. Okay, let's move. Can we go? I hope everybody has constructed his or hers. Have you constructed yours or you are yet to? I need their own so. That's why I'm going to say. What if I said the answer on, but this one there, I am going at the pace of snail. Now, what next are you going to do? You are going to pick your ruler, and that is why I usually advise geography students. Apart from your mathematical set, there's a ruler which is also known as 1 foot ruler. 1 foot ruler. If you have 1 foot ruler, constructing 18.35 will be easier. Okay, so now what do we do? we are going to construct a triangle. And this triangle is nothing new, but we are connecting the beginning of line, the line 18.35, to the perpendicular line you have constructed. So at A, you have constructed a perpendicular line. Some of you 1.1 centimeters, 2.2 like that. So at the end of that 2.2 line, all right, you are going to connect it to the other point on the first line, the line 18.35. I don't know whether you have gotten me.
Sir, Doc, take it again.
So I said you are going to construct a triangle now. So you are connecting line. Okay, maybe we have to number or label the lines so that at least I can make reference to them. So let's go back. Let's restart. Line, the 18.35 line. 18.35 line. That's where I am at the moment, correct? That's where I am at the moment. 18.35 line. Okay, so let's label that line. The beginning, the beginning of it from the left. Let's label it O. Just for the sake of what you're doing, let's label it O. And the end of that line on the left, sorry, on the right, we have already written A. So we have line OA. So when I am referring to any line, I can say line OA. Okay, now the perpendicular line that you have drawn, let's label it A prime. A prime. Are you there? So now we have labeled all the lines, so I can make reference to it. So all that I said is that we are connecting A prime to O. A prime. We are connecting it with a straight line, a slanting line. Your line will be a slanting one. So A prime is connecting to O. Yeah,
And you?
Okay. So what do you have? What shape have you formed? I will entreat you to go apart from the math set, to look for 1 foot ruler. Also, 1 foot. So that you carry it with you when you are going to write your quiz or your exam. I have one here. Mine is lying right here. My 1 foot ruler. It is still working. So what shape have you formed? Doesn't it look like a triangle? A certain type of triangle?
Yes, sir.
The triangle has 3 sides. Okay.
Yeah, it looks like.
So that's what I'm talking about.
Okay.
An example of such a triangle can be found on slide 49. Slide 49. You have such a triangle there. Okay, we are not done. You are going to do another exercise. Now, let's go back to the measurements we took, where you wrote AB equal to this, BC equal to this. You remember that one?
Yes, sir.
Remember that one?
Yes,
okay.
Sir.
So each of those measurements is also going to be divided into 2. So if you pick the measurement times 1/2, which will give you that measurement over 2. So do that all the way from AB, BC, CD, DE, and EA. Do that. Calculators are working, or your phones. These days, it is phone, so everybody is on phone. I can see some of you didn't join this online class because I have about 15 of you, or 17, or 16, whichever. Less than the number I've been having. Okay, so you now have a scaled distance of AB as plotted, a scaled distance of BC as plotted, a scaled distance of CD as you have plotted it, D, and then EA. These are the distances you have, new ones. Please write them down because we're going to use them. Captured? Finished?
No, sir.
Okay, then let's double up a bit. So make a mental note of the processes you are going through. Make a mental note of the processes you are going through. And these are, I may have to get additional time still. In other words, we can go through another adjustment if in case you are unable to understand this. All of you done? Who is not done? Okay, I take it that all of you are done. Now let's go back to line OA. Line OA, line AA prime, line OA prime. The triangle you have formed. Start from O. Start from O. Measure the line BC that you just calculated, that you just divided. What did you get? Let's say line BC is supposed to be 7. You divided and you got 3.5. So go on to line OA and measure 3.5. On line OA, starting from the left. I'm only using 3.5 as an example. Maybe your AB is more than 3.5, right? Maybe it is. But so whatever figure you got, measure that on line OA. Have you gotten it? And mark. Make a small mark where it ended.
So are we multiplying with the same factor?
Back.
My light went off, sir.
You know that. Okay, I don't blame you. It's the network. So scale factor something there. Yeah, come home. You have gone past that stage. So where did you
Okay,
get
go on.
No. Let's clear.
The measurement of line AB 7.25. That's what I got on the triangle.
Plotting.
Yeah. So I should
On
measure
the triangle.
from, yeah. So line O, I should measure line OA, I should measure 7 point. What I got?
I know measuring 7 point. What you got?
It's
Okay.
3.6. 3.62. 3.63
Yeah.
rather.
What you are doing is
That's
that
what I said.
maybe you measure.
That's what I said. That's why I said they should divide by 2.
Yes, when you divide by 2, you get 3.63.
Okay. You are good to go.
Okay, so there, where your 3.2, 3.1, 3 point whatever got to, mark that place and write B at the bottom. B under it. B. The alphabet B. Now, that mark that where you have written the B, extend that line straight. Go and hit line A prime O. Line O A prime. Let it go and hit it. I hope you understand what I'm saying. It is going to hit it. Extend that line to join line O and A prime. That's it. Okay. Now on top of that one, you write B prime. On top of the B that you wrote, and where your extended line joined O A prime, write B prime. B prime. Okay. Okay. So go to whatever you got for line BC when you measured, and when you divided, what did you get? Because we divided by 2, if you remember. What did you get? The original figure should have been 5.19. So if you divide, maybe you got 2.5, 2.55, 2 point whatever. That figure is what I'm talking about. That is line BC. So go back to line OA. Line OA. Go back to line OA. Start from where the B is on line OA and measure the 2.5 or the 2.55 or 2.6 that you got for BC. Measure, and when you get to the end of the measurement, you put a mark there or a dot. Put a mark there or a dot. All right. Now, having done that, under it, write C. C, alphabet C. Okay. Now, extend that mark or that line where you have written the C to go and touch OA prime. Extend it to go and touch OA prime. Ordinarily, this line you have constructed at C should be longer than the one you constructed at B prime. Ordinarily, because it is a certain type of triangle. Is it isosceles or what? Yeah. Okay. I hope you have done that one too. Now come to CD. Come to CD. You measured and got something in the region of 3.65, 3.6, 3.7. You are dividing this figure by 2, by the scale factor, divided by 2. I hope you get it. So what do you get? You get about 1.7 something, 1. Oh, is it 1? Yeah, 1.7, 1.8.
1.8%.
You understand? That's what you get. Okay. So with that 1.8, 1.7, 1.9, you are going to stand at C on line OA. On line OA, you're going to stand at C and measure the 1.7 on line OA. After measuring it and getting to the end of the 1.7, 1.8, you put them out there. Mr. No, but I'm not saying this. I hope you can hear me. Hello, can you hear me?
Yes, please.
Okay, good. A call came through and it's just a disturbance. All right, so you have measured 1.8, 1.7. So under it, you are going to write D. You are going to write D. You are going to write D. And then you extend that line also to go and touch OA prime. And on top of it, you write D prime. You write D prime. Okay. So we are now at DE. Is anybody lost? We are now at DE. At DE, the original measurement should be 9.3. 9.3. So you plotted, maybe you got 9, you got 9.2, 9.1. You are dividing this 9.1, 9.2 by 2. So that will give you about 4.5, 4.6, 4.4. I hope you are following like that. So whatever you got after the division, carry that figure, go to line OA, and start from D prime, start from D and measure the 4.4, 4.5, 4.6. 4.4, 4.5, 4.6. Whichever figure you got, measure from D, you get to a certain point. When you get there, the same way, mark, and underrate.
I thought you were calling me.
You thought I'm doing what? Oh, a call has come through, and anytime it comes, I cannot pick it. So there are only two options: either I decline or I accept and end the online. I will not end the online. When I finish, I'll call the person. All right. So let's continue, please. Let's continue. So you have measured the 4.45, 4.2 that way. I hope you have measured it. Okay. So make a mark there where the 4.4, 4.3, 4.5 and so on ended. All right. And under it, write E, the alphabet E. After writing it, you extend that mark or that point to go and touch OA prime, like OA prime. And on top there, you write E prime. On top there, you write E prime. Okay. So you can go onto the slides. I mean, those who have opened it or can open it. I know some of you are using your laptops, so you can open. Slide 49. What we have done is there. And if you go to slide 54 to another one is there. Just what we have done. The same thing is there. Okay. So we are done with this phase. Any questions so far before we move to the next one? Any question? Okay. I take it that we are all home. Let's move on.
What was that?
Let's move on. Yeah.
I don't know. Since you said this is the first time, this is the last this time is the last time we will not become at this again. If you can take it again, I'll be very happy. Because for me, let's see.
I can go.
We can go through it again. I'll be happy because when you divide the lines by the lines by maybe AB, you divide by the scale factor, which is 2. Whatever you have, where do we? And the way you also label the line, I'm a bit confused because when I check, I'm looking at the slides here, and when you look at the slide 48, the line that is drawn A, the way we label it, I'm not seeing the label. Is that sample label here? That is A O.
That is what is no. That is what is in the book. All right, you can adopt your own labels.
And then
because you are struggling.
Yeah, I said also, and then my main confusion is that let's say I divide line A. Where's the work here? Yeah, I divide line AB. I had a 7.5, so we divide multiplying by the scale factor 0.5. I had 3.75. 3.75. We've already formed a triangle. We've already draw a line. The first with the this in the gap between A prime and A. We divided by 2. Whatever we had, I had 2.1. We divided by 2. We draw a horizontal line which we use to construct the triangle from the top to the end of the other end of the line, making a triangle. So now that we are plotting the lines between them, just like it's on the slide here, my problem is that if I get if let's say 9AB for instance, 3. Dividing I got 3.75. Which part of the line will I put it? Which part of the triangle?
You have not been following. Because
not really, because I got confused. I didn't want to stop you initially, so that
no. Then what you are doing is even worse because now you are telling me to go and start afresh. That's why every step I ask, I pause, so that if you are lost, you have helped there and then we move on. If you wait till we finish and you want us to go and take it again, I hope you understand what I'm saying.
Yes, sir.
There is no difference between what I am telling you and what is on the. If you like, go to slide 54 and check what is there. If you check slide 54, this is a manual kind of plotting. You see that it is the same thing we are doing. The A, B, C, D, and so on are all there. So if you get confused and if you don't draw our attention and you let us finish before you want us to come and start, it is a waste of time. Because as for the plotting, we have the triangle, the distance that we are done with it. So if I should come and start again, it is difficult talking. That is why at every step I pause and wait whether anybody has any concern.
Sorry for that, but
so that I address it.
Yes, I not that I don't understand the whole thing, but actually looking at slide 49, where we have the the B, and then the B prime at the top, C prime at the top, D prime at the top. So that is exactly why.
No, but is it even the slide 49 that we talked about? Is it not the same as we have done? This one, the alphabet are different. This one is up to F. It's just a sample, something that he did. But the proper plotting is on the 54, slide 54. If you look at slide 54, you see that you have B, C, D, E, and the A and A prime are to your right. Have you seen it? I didn't want to do anything different from what you have on your slides. That is why I did it this way. I could have done it in another way. So you start from where there is the left, where there is no label. All right. And that is the line AB. You measure line AB. Okay. You measure line AB and make a mark. All right. Now the mark you are making, that is where you are going to write the B. After writing the B, you extend it to touch. I intentionally gave you the O because it is only the O which is on the left, which is not on the slide 54. That is the only alphabet that is not there. I did that because you were struggling to, follow or know which line I was referring to. As I said, you put the O there. Okay, so it is only the O. On slide 54, you don't see the B prime, you don't see CC prime, but it answers the same question. What you have done, you can clear the CC, the B prime, the C prime, and all of them. You can clear them. But they are important because we are going to use them to construct another plotting. We are going to use them in plotting another one. All right. Because and that will be a reflection or a shadow of what we have plotted already. That is why it is always good to bring the prime thing. So there's no difference between what we have done and, for example, what is on page slide 54. If you are watching, the only thing you are not seeing on 54 is the O at the beginning, which is an improvisation. You can take the O off; it doesn't mean anything. And then the prime at the top. That is the only difference.
Yes, I'm getting the point now. It's like, so it means that we are the plotting is done on line A and O. Between line A and O, that's where your lines are being plotted. I've gotten it.
Oh, that's all. So you plot it there, and then you extend it to go and touch the slanting line.
Yes, yeah. Thank you, sir.
And those lines that are touching the slanting line are not for panel. They are the ones we are going to use. So we are not done at all. Okay, having cleared this doubt, let's move on to the next stage. The next stage is that we are going to use, because some of the perpendicular lines are very, very short. We are going to use the divider. Use the divider to measure the perpendicular line at BB prime. And then when you finish, you send it onto your ruler. You get a certain figure. Record it against line AB. Yanko. Did you hear? Oh, somebody is making noise at the background. Noah.
Sir.
There's noise at your end. All right. I hope you heard what I said. The lines are tiny. Ideally, you should be using ruler to measure B prime. That line, that vertical line, very tiny. So to be on a safer side, use the divider. When you have gotten it on the divider, you come and measure it on the ruler. Whatever you get, you record it against AB, like AB. Then you do the same thing for CC prime, the vertical line. The ruler may not give you a clearer picture, so I prefer using the divider to pick the measurement. I prefer using the divider to pick that measurement. When you finish picking it, you send it onto your ruler you measure. Whatever you get will be recorded against BC. Then you go to D. D. With your divider still, you pick the measurement of that vertical line. The line from D that touches our OA prime line. That line. You use the divider to measure it. Take it, bring it onto the ruler. You have some measurement. You record that one against CD. Against CD. Then you go to where we have the E. You go to where we have the E. The same thing. I prefer the divider here. Use the divider, get it accurate, transfer it onto your ruler, and measure. Whatever you get, you record it against DE. You record it against DE. So Azima, don't worry. Maybe when I'm done with this one, you pick the one we did last week. That one will be simpler. You pick that one, and then try and see whether we can adjust the traverse. That one is simpler. That one you will not do the divisions that we have been doing. Apart from the divisions, all other ones and all other steps are the same. Okay. So now you have gotten your DE. What is left at AA prime is supposed to be for EA. It's supposed to be for EA. So you can measure that one too. So with your divider, you pick that measurement, you transfer it onto your ruler, and you get a certain figure. You record it against EA. Now, what have we done? What we have done is that gap that was there has now been spread, has been distributed over all the points. I repeat, that gap that was there has now been spread over all the points, point B, point C, point D, and point E. We have spread them over. That is why I started by saying that the Bowditch method seeks to distribute the error over the points. It seeks to distribute the errors over the what? The points or the stations. That is what we have done. And that is not the end though. We are now going to go back to the original plotting that we did. We are now going to go back to the original plotting. Iman, your hand is up.
Yes, sir. Sir, please, which perpendicular line do we measure to get the EA?
Which perpendicular line do you measure to get EA?
EA.
I said, what is left? That was what we even started with. The line at A and A prime. All right. And that's why we measure. But usually we leave that one out. You know why? Because that is a gap. That perpendicular line there is a gap. So we don't normally even write it. We leave it out. But for the sake of filling the column, you can still measure it and put it there. But actually, when we are doing the correction, you start from B, come to C, come to D, come to E. From E, we shall go straight to A. We shall go straight to A. So the measurement at A prime will not be used. Just that we are using it to fill our books, our column. All right.
Okay.
I hope the man is okay.
Yeah, I'm okay. Thank you, sir.
Okay, so let's go. So we are done with all the mathematics. We are now going to geometry. You're going to go back to the original process, the plotting we did, the diagram that we plotted. Now, with the figures we just wrote, which I believe you did, we are going to construct, I repeat, we are going to construct perpendicular lines from the center of each of the setups at at B, at C, at D, and at E. I repeat, we are going to construct perpendicular lines that stand at the distance you have written. So if you got, for example, A prime, B, all right. If you got, I'm talking about line BC, for example. If you got, or line AB, if you got something in the region of, say, 1 point, no, it's 0.2 or 0.3, you are going to construct a straight line from the center of B standing at 0.3. I hope you are following me.
Sir, I'm not clear with that one. Are we going back to the original this thing that we started with, or get the one we get finished?
When I'm speaking, you've got to pay attention. I have repeated myself.
Sir, like it is threatening to rain, so the network is somehow slow. Sorry, sir.
So this is what we are going to do. You have just copied some figures. The last figures you copied, they are the ones I'm talking about. All right. So line AB, which will be constructed at B. If you got 0.1 centimeters or 0.2 or 0.3 centimeters, you are going to construct a line that will stand at 0.3 centimeters at B. If the second one you got 0.5, you go to C. All right. You go to C where we have plotted the C, and then you construct a line that is standing to that length in that order. So let's start. As you move on, you'll get the understanding. So go to the figures you wrote. That is line AB. Look at your figure. What did you get?
No.
Okay. Yeah.
You know, on the one that we plotted, already there are some, what do you call it, perpendicular lines. So can we just measure from those ones?
No. We are not measuring from those ones. You are not measuring. You're going to construct our own lines. And those lines, as I said, they may not stand at 90 degrees. So let's go one step at a time.
I want it to be double lines at the same place. That's what I'm.
No. So you listen. In constructing those lines, where the lines will go, whether it will go to the top or down. In fact, these are the two directions where the line goes, either to the top or to down, either to the top or down. As to whether to go down or go up depends upon where the error occurred or where the plotting started from and where it ended. In our case, it was going up. Okay, it is supposed to have gone up. Therefore, all our lines are also supposed to go up. You started plotting from a top A, then you descended, then you descended, then you descended, then you had almost a flat something. Then you were climbing. You're supposed to have climbed all the way to A, but you couldn't get to A, you go to another place. So if you are adjusting, the lines that you are going to draw now must also climb. They must go up. They must go up. So come with me to B. Come with me to B. Are you there? Use your ruler. Use your ruler. Come with me to B. Go to where we did the dotted lines on A prime. Okay. Put the ruler just by the dotted line. All right. When you are there like that, you are going to slide the ruler at the same angle where you place it. You look at where the dotted lines are. Put the ruler on the dotted line, because if you did the dotted lines well, you will find that it is a straight something, because you use the ruler to do the dotted lines or the broken lines. So put the ruler by the side of the dotted line. Okay. Now you have gotten the angle of the dotted line. Don't remove the ruler. You can slide the ruler all the way and place it at the center of B, the cardinal setup at B, so that you have equal measurement, something like if you want to rule line between where you have placed your ruler at B and the perpendicular line, you almost have two straight lines by your imagination if you are using your eye to cut the line. I don't know whether you understand it. So at this position, when I say, just let me, because I know these things, they are not taught online. You should have been on the board. Into the area, and say what we are doing is that the angle at which the dotted lines are lying will be the same angle at which we are now going to draw our lines at the various points. Have I made myself clear? Okay, so I take it that all is clear. So when you get to the center of the cardinal at B, if you get to the center there, ensure that you have two diagonal lines, one formed by, with your eye, one formed by the dotted lines, one formed by the ruler you have just placed there. Now with this ruler, and from the center of your cardinal setup at B, you are going to measure and rule line 0.2 according to what you measured and wrote. And that line is going up, is going to the top. So if your AB, the last figures we copied, if you have 0.1, you are ruling a very short line at point D, standing at 0.1 centimeters.
Yeah. Are we using the measurement that we used to draw the distance when we divided the C factor and then we had 3.2? Which measurement are you
Yes, I am. Willie, what's the issue? Williams, your hand was up. Okay. So what was the question? Because the things I keep repeating them, but still. Huh? Mhm. That is why those who are taught by Mr. Online how they talk, because you will not have the patience for you like this. It's quite cumbersome. So we are using the figures we copied, the last figures. Huh? The distributed figures, they are the ones we are using now. The figures we picked from the triangle we drew, they are the ones we are using now. Who was talking? Was it Mohammed or who?
Sir, Desmond.
That's one. Yeah. Have you gotten it?
Yes, sir.
Okay. So
Now,
So at B, I've told you the angle at which your line is going. You see, at the end of the day, we are going to provide a shadow of the diagram we plotted. So that shadow should look the same as the diagram we plotted. Therefore, if you are constructing the lines using the measurements I mentioned, the lines should be at the same angle as the gap. They should be at the same angle as the gap. So that's why I told you that for A, for example, if you want to construct A with your ruler, just put the ruler by the dotted lines, the gap. Put it there. And then don't remove it too. Just slide it. Slide the ruler on the paper at the same angle where you pick the dotted lines. And then land it at the center of your cardinal setup at B. When you have been able to do that, look at the figure, whether it was 0.1 centimeter, 0.2, 0.3, then construct a very tiny line standing at 0.3. That line should go up. It shouldn't come down because the plotting was from the bottom and it was going up. So that's why I said this one is technical. One, yeah, it should go up. So it goes up there. Very short line. And I'll tell you how we're going to use this line. Okay. So let's go to the next point, C. If I were you, I'll just follow the angle at which the gap is lying. I mean the dotted lines. And I'll push the ruler to the center of C. Okay. Now when you are at the center, you are going to construct a line up toward where you wrote the A prime up. It will not come down, it is going up. But that line is not ordinary line. It is according to the figure you got for DC. And what figure is that? Your figure, not my figure. So it will be about 0.4, 0.4 grados, 0.3, 0.35, and so on. So your line should stand at 0.35 centimeters up. And on the same plane, at the same plane as the dotted lines. Okay. Any trouble? Any trouble? Yeah, why? After this, the rest will be just some lines. Okay. I take it that everybody is home. Now let's go to, we are done with BC. Let's go to CD. Let's go to CD. CD, the same thing. You do it at D. So look at the angle, how the dotted lines are standing. And make sure your line, which will go up, is forming the same interval. It's on the same plane as the dotted lines. Okay. Now, what is the figure that you copied from that point? What is the figure? It is saying figure ben, maybe 0 0.6, 0 0.4, 0 0.5, and so on. You pick your ruler. If I were you, in Kaminya angle, no cram the dot be so, I'm the ruler not to. I'm a measure, not to. You pick your ruler. Make sure it is lying at the same angle, the same slanting angle as the dotted lines. And then you construct a line up, not down, up, measuring maybe 0 0.4, 0 0.5, 0 0.6, 0 0.7, in that order. In that order. Depending on what you got. Okay. I hope you have done it. And the last one we're going to plot is DE. DE. If you do ruler not to her, now we angle of the dotted lines. Any dotted lines now say what the same angle. Okay, so you place it at the center of your cardinal setup at E. And then what do you get? Something in the region of 0.6, will be 0.7, 0.8. So the lines are not too long at all. They are just short lines. Okay, 0.8 and so on and so on and so on. So you construct a line up, still up, because the plotting is going up or supposed to go up. So it should go up. But it should be on the same plane. Said there, those who understand some trees, said the dotted lines, achiano. I was saying also chia, and then in chia and yeah pepe. I was saying so. Okay. Those are the technicalities. So you can't do it anyhow. There are technicalities involved. Okay, now I believe we all have done it. Who is lost? Why be there? But those who are following the plotting carefully, at least you are getting the idea. It is not easy doing this, but I tell you, if you become conversant, it is easy. That is why we call it practical jog. Practical jog, you always have to practice. You always have to practice. So we have a certain line at B, a certain line at C, D, and E. Yeah, we are, me. Say, yeah, we are, just tell me. Yeah, we are, catch me. If you are all done, let me know so that we move to the next and the last thing for such a work. Is everybody done?
Yes.
Okay, good. Now pick your ruler again. That's the last thing. That's the last plotting. And the traverse would have been fully adjusted. Ruler. Okay. Pencil. All right. Put your ruler at the center of A on the plotted diagram. Let it be at the center. All right. And let the other side of the ruler, the other end of the ruler, touch the end of the line you just constructed at B. Manenkoto line up on top of it. So now you have the center of your cardinal setup at A and the tip of the line you constructed at B. Are you there? Are you there?
Please, Doc. Is it the point we place above the B, the perpendicular B from the A prime?
You constructed a certain line, which I told you should be at the same angle as the dotted line. The lines, the small lines that we just constructed, that is what I'm talking about. Every step, there's something we are doing, so you have to follow. We are not talking about any other line apart from those that we just constructed, or you didn't do it.
I did it, please.
So at B, the line you just constructed at B, if you got the angle right, that is the line I'm talking about now. So put your ruler at the center of A and let the other end of the ruler be at the tip of the line you constructed at B. Are you there? Everybody?
Yes, please.
The one who was talking, are you okay now? Noah? Or
Yes.
it was no Noah? Okay. Now, at this position with your ruler, you are going to connect the 2 points with dotted lines or broken lines. Broken lines. Broken lines. As for the length of those broken lines, it is according to your style. Gotten? Gotten?
Yes.
Okay. So we are moving on. Now the next thing to do is to place now the ruler. Place it at the tip of the line you just constructed at B. The line that you have just connected with dotted line, that same line at B. Place your ruler there at the tip. So invariably, the ruler is now lying around the same area where your dotted lines ended on that line. And then the other end of the line must also be at the tip of the other end of the ruler must also be at the tip or lie at the tip of the one you constructed at C, the line you just constructed at C. So it is now tip to tip, the tip of the line or the end of those lines. So the end of the line you constructed at B and the end of the line you constructed at C, they are now joining. Have you gotten? Okay. I take it that you have gotten it. Now, at this position, you are going to provide another set of dotted lines to connect the two. So you connect them perpendicular.
D, right?
Have you gotten it?
So we connect C and D too.
Oh, one thing at a time.
Okay.
Let everybody finish what you're doing. So if you are done, let's connect the one at C and D as you asked.
Okay.
The one at C and D. Yeah. So you connect with dotted lines or broken lines. Okay. So if you watch, you will find that the dotted lines are lying almost symmetrical, huh? Providing almost like something like a shadow. Correct. Let's go. So we are now at D and E. We are now at D and E. I hope you are there with me. So connect the tips of the two lines you did. And at D, you see that your broken line will cross the line EA. It will cross it. It will cross it. I wish I had somebody here to hold the camera for me so that you see what I'm doing. I'm alone here. So we are almost there. I hope everybody is where I am at the moment. It's interesting. Then the last one, connect the tip of that line at E to the center of A, not A prime or A. It should be dotted lines, broken lines. So, dotted lines, broken lines. Safini?
Yeah.
Who is not at this stage? You say man I'm a man online also. So apologies. I don't mean to denigrate you.
Sure. As for me,
Yes.
I'm heading back home. So at the point, I had to pause.
Why? Were you at the workplace?
Yeah. So I'm now heading back
Mm,
home.
I see. So I have Ellen, I have Maggie, I have Vanessa, you are here. And I'm into Nkano. Oh, only 3 women. Okay. So you have seen that there's almost something like a shadow around the plotting we did. And that is the distribution. We have distributed that error over all the points. So now if you want the actual diagram, how the diagram should have been, it is the dotted lines, the dotted ones, the one we just did. That is how it should have been. Because there was an error, we had to adjust it as we have done. So the dotted ones are the adjusted traverse. The dotted line has provided us with what? The adjusted traverse. Somebody will ask, why is it that from A to B, it looks so narrow? From A to B, it looks so narrow. As I told you from the beginning, you are never, the error will not start at the point where you started. All right? The error will not start at the point where you started. The error will occur after you have moved away from the starting point. So there is no adjustment at the starting point. At the starting point, there is no adjustment. Okay? And so that is our adjusted traverse. Any question? Yeah, anyway. But in fact, what I'm taking you through is a high order one. Usually, we don't do the divisions. We give you straight one. So like the one we plotted the other day, that one, you could have gotten your line straight without doing the division. Now, one thing you have to also notice that as soon as you do your summation, as you did and got 36.67, as soon as you do it, and it is too long for you to draw and that you have to scale it down, any other measurement must be scaled down accordingly. Any other measurement. So the gap must be scaled down, all right? The division of the line OA prime, OA, in our case, line OA must also be scaled down and so on. Those of you who are watching or who are looking at the slides, look at something on slide 50. Slide 50. And let me explain something there. If you are looking at it, if not, you can have a look at it later. You see that slide 50, the plotting started from the left. It went down, it went down, it went down, it went up from B to C, it went up, C to D went up, D to E, it was up, then E to F, it came down. So from F, you should have no from E, you should have ended at E, but it ended at F. So if you check, you see that the same way we did, because the plotting started and it was coming down, those lines that were plotted also came down. Now look at from A to B on that slide. You will find also that the dotted lines are behaving just like what we have done. As I told you, you don't adjust anything at A. A is the starting point. So the adjustment will start from B. That is why the dotted lines behave in that manner. All right. That is it. Then if you go to slide slide 55, you see some colors in the blue and red colors. The red is the dotted ones and the blue is the original plotting. So a shadow has been provided. It isn't always the case that it will look like it. A traverse can be any shape. So if you are giving one, you plot and it doesn't resemble any of those that you have seen, don't worry. Provided you follow the instruction, you are okay. So that is how to adjust traverse. Maybe, because if I want to use the allotted time by UCC to take you through some of these things, check how long it has taken us. The whole time. We started just around 6:12. I watched the time. Around 12 minutes after 6. And now it is by the watch I'm using, some 30 minutes to 9. So not less than 2 hours or even more have been spent on this thing alone. So if you want to use what UCC has given us, you can't do any other thing. But there are two important things I should do with you. The rest you can read. But there are two important things. We will plot a linear scale. And then we calculate area. You do calculation of area. These two. Apart from this, the rest you can read and understand. Okay. So you revisit scale. You look at the two types of scales. All right. Did I say two? The three. The statement, the RF, and the linear. And then you crown it with the plotting of the linear scale. Okay. Then I'll leave the rest for you to read. I'll give you the slides for all the units. I'm left with unit 4 and 5 to give to you, which I will do. Okay, so maybe if you want us to try another adjustment, which will be easier than what we have done, then maybe you will need some 2 hours additional time somewhere. Probably next week. Monday. Eh? Because we meet on Tuesdays. God willing, next week Monday we meet around this time. Try and go through the adjustment once. As for the plotting, I know you're okay with it now.
Doc, please, Monday, geography, political science people have class Monday. So Monday
Okay, so when are
evening,
they free?
it can be Wednesday
Doc,
since
can't
we
we
have
do
lunch.
it Thursday?
A week today, yeah. Wednesday I have online with sandwich. The same course, surveying with sandwich students. So Thursday, the same day, the same time, next week, God willing. I think we by that time we would have met on Tuesday and would have seen where we will reach. So I can even gamble. I can use the Tuesday time to let us go through the adjustment once more. As for the plotting, it's okay. I hope all of you have picked it, the plotting. I can let us go through the adjustment
Yeah.
once more. When you pick that one too, then we move on.
Okay,
And
sir.
remind me, let me give
No,
you some
thank you.
past questions. Yeah, let me
Okay,
give you
thank
some
you.
past questions. Yeah, after or yeah, after today, I'll put my eyes together and get you the past questions. All right. So on that note, we are coming to the end of our unofficial meeting. Yes. I hope, are you aware it is recorded? It is. The guy appeared, and when he saw that I had started, he left, and the recording is on, and that is a good thing. So it is recorded. So Tuesday, God willing, we shall meet. I'll gamble. We will do another adjustment, which will take us shorter time than today, and from there we'll move into other things. In fact, there are so many things we have to do because we have to do bearings, calculation of bearings, and so on. It is still here with us. So I'll do all of that, God willing, on Tuesday. And Thursday, when we meet like this, we can continue. But by that time, we would have been okay with the adjustment. And one new, yes, you remember, you know, can't come in. I wouldn't sleep this night. I would be going over, so that we become conversant with it. Minus any other question or concern, I want to bring the class to a close and say thank you for your patience. It has been a hectic time, and so it has been, so it is, because teaching some of these things online, there it doesn't come easy. Even on the board, crowd, people struggle, let alone online. So, yeah, but the actual man could go and practice, start, practice, start, practice. The plotting, you're okay, but we have done it twice. You practice with it, all right. So go and practice the adjustment. What we have done is the craziest anybody can get. Where you have to scale the distance down and so on is the craziest. So if you're able to grab this one, when the simple one comes, to be fine. But I never thought, I never examined this to see that it was going to be the scaling type. I would have started from the other end before getting here. I saw good. All right. Thank you very much for coming. I hope to meet you, God willing, on Tuesday. Good night and bye bye to you all.
Good night, Doc.
Good night, Doc.
Vanessa, Vanessa, is she gone?
Yes, dear.
Aha.
I'm
Can
here.
you? Yeah, this is Noah Kumase.
Okay.
How may I get your number? Because I have lost it.
0246
All right.
00
Okay.
59
Mm-hmm.
18.
18. Okay. Thank you.
Kindly repeat it for me.
All right. I will.
Okay. When you even call Margaret, she will give it to you. Okay.
Uh, yeah. I know.
Thank you.
Hey, Noah, my
I,
screen is not working. No. So when you
Hey.
call, I'm not even able to see to pick.
Uh-huh. Because the last time I called you, you see I requested for Vanessa's number. Uh-huh.
I'm not even
I
seeing
thought,
the screen. They are suffering here.
oh. Me what fancy for the aboho.
Ready, I'm young castle.
Afra.
See the abo.
What's the bishop on car?
Baby,
After any 4 or 5 days, and I'm a friend now. Okay, so the last time I back class and we did there 40 minutes. Nah, not sure if you see what I do because that's a maintain a voice in there. A friend. And I'll call Britannia.
oh, that
Oh, call on Pianco. Bishop or Koya, sorry, or how I'm Yankobi.
What's actually right?
Okay.
I will say
Bye.
BBI. Bye.
Oh, yeah.
Mali sai ya ce a'a abin da nake nema ba shi kasar Mali ya kamata in tashi in bar garin Mali. Sai ta mutu garin da ake ce ma Niger. Akwai wani bakin ruwa nan ya zama sauran zangonsa yana karantarwa. Mutane gari da suka hasken wannan magani sai suka runguma baki ɗaya suka zo neman tabarrukan wurin akallin namu Muhammadu Bello. A nan Nijar ya samu almajirai da dama, to amma sai ya nuna musu ba manufa na ne nan Nijar